Uh, Hello everyone. Today we'll do some examples by using uh, unit load method. Let us consider one examples using unit load method. So let us consider one example. So here let us consider one examples. Determine the deflection at load point for the cantilever beam shown in figure using unit load method. So this is a given example. So it's a cantilever beam subjected to a point load 10 kilonewton, and it is 5 meters, and length is 5 meters, and this is fixed end is A, and free end is B. We need to find out what is the deflections at point B by using unit load method. This is a given question. So we need to find out what is the deflections at the point this thing. So now let us start doing this problem. So let us consider this. So there's a given beam. So it is subjected to a point load. So it is subjected to a point load of how much? 10 kilonewtons. 10 kilonewton. And this is end A and this is end B. We need to find out what is the deflection at this point. So this is the total length is 5 meters. So your first step is to what is that? Your first step you need to find out the what is the bending moment due to external load. So you know that what is the formulas for unit load methods? What is the formula for unit load method? Deflections due to unit load 0 to L capital M max into small m max divided by EA into dx. What is capital M max? Is the bending moment at a sections due to the external loads, and small m max is what? Bending moment due to the unit load. So now let us find out capital M max. What is bending moment due to external load first? Then let's take the same beam. So then let us find out what is the bending moment due to external loads. Let us take one section at this point. Let us take a section at this point. So this is the free end x from the free end. So then what is the bending moment capital M max? What is that? Bending moment due to external load. Then capital M max equals to load into distance. What is the load in distance? 10 into x. So bending moment at this point will be 10x. 10x. Now so we need to find out what is the smallest. What is smallest? Bending moment due to the unit load. Now what is the next step? Now whatever the loading is there, you remove all the loadings from the beams. You remove all the loading from the beam. So this is a given example. We need to remove all the loadings from the beam, then apply unit load the point where you need to find out the deflections. So at the point I need to find out the deflections. So then remove all the loads, then apply unit load at the point B where you need to find out the deflections. This is unit load method. So now let us see. So I removed all the loading from the beams, applied unit load the point where we need to find out the deflections. That is a very important steps. This is a point B, and this is this is A and this is B. Total length is 5 meters. Now let us say same thing. You need to take a sections at a distance x from the free end. So find out what is small x. Small mx is what? But this is what? Bending moment due to unit load. Unit loads. Then what is small mx? Small mx equals to 1 into x. So it is 1x. So 1x is the bending moment due to external. Now put it in a deflection formulas. What is the deflection? Delta equals to 0 to L capital M max into small m max divided by EA into dx. What is capital M max? So 0 to, what is the integration? 0 to L. What is the limit? It is a 5 meter. So length is 5 meter, right? Length is 5 meters. So it is 0 to 5. Capital M max is 10x. Small m max is 1x divided by EA into dx. Now do the integrations. Then I can write delta equals to you can take delta equals to, so x square, you can integrate it, x cube by 3 0 to 5 into 10 by EI. So 10 by EI. So I can write, then this I can write, what is this? 10 by EI into 5q divided by 3. So I just get delta equals to how much? 416.66 by EI. This is the deflections at the point B. This is how we need to do it, guys, please. So please remember, what is that deflection due to unit load? This is a formula I am going to use. So what is the delta equals to integration of 0 to L. Here capital Mx. Capital Mx is what? Bending moment due to capital Mx is what? Capital Mx is what? Bending moment due to external load. Small mx what? Bending moment due to unit load. So unit load. So first you need to find out what is the bending moment due to external loads. Then remove all the loadings. Apply unit kilonewton where you require your bending. Then find out what is the bending moment. Then substitute in these formulas delta and find out what is the total deflection. This is how we need to